State the nature of your inspirational emergency. Because we have your treatment protocol, the Star Trek NASA panel. But first, a message from the captain.
NASA works by science. O-rings better work, amount of energy, the thrust needed to lift and free ourselves from gravity, the mathematics involved in setting an arc there because you want to land over there, all that's mathematical. But science fiction is totally imaginative. It's the exact opposite. What happens if light that is bent and you could go through the center and make it quick? All these imaginative exercises in science fiction is merely food for the imagination of scientists who are actually working with technology that is. Imagine sending a vehicle to take a photograph of Pluto and come around and take around and then move around and keep going. You can't do that on a motorcycle. I mean, you set your course on a motorcycle. If you don't hit your line, you're going to fall. Oh, you're taking it around there. It's phenomenal what NASA is doing with science that is, when you look at it, is the equal of science fiction. How are you going to make a parachute that's going to stop a vehicle and pop, it pops out and it's going to stop it? It's not a miracle. How much line do you need? What should the material be? How do you slow it down before and then you got to send a signal, and is it 7 or 9 minutes later the signal? I mean, it's science fiction. Shadows that cross in front of a star that suggest there's a planet. And it's big enough planet to be the size of the M1 of the Earth. Is it possible that life exists on that planet that's only a shadow in a telescope? Those are the imaginative things that NASA are looking at that's every bit as passionately imaginative as science fiction. But you guys are working on it. It's incredible.
To seek out new life. My first question is for you, Amber. How will the James Webb Space Telescope and future telescopes help us in our search for life in the universe?
Oh, yeah. So the James Webb Space Telescope, first of all, how many of you have heard of it? Be honest. Oh, yes. Okay, so we're still a few years from launch. So a lot of times in a crowd when I ask that, it's only maybe 10% if I'm lucky, but y'all are in the know, which I love. So the James Webb Space Telescope, we're building it as the successor to the Hubble Space Telescope. And so all said and done, it's going to be about 100 times more powerful than Hubble. So it's going to be amazing. So this awesome picture here and videos that are showing give you a little glimpse of it. And I hope what you can see in here is how big this thing is. It is by far the biggest telescope that we've ever sent into space. It's so big that we have to fold it up, put it inside the rocket, and then it deploys once it gets into orbit. It's about 4 stories tall, top to bottom, and it's got a massive sun shield that isn't shown here. It's about the size of a tennis court, to give you a sense of scale. Like, absolutely wouldn't fit in this room. So it's huge, and we need this huge telescope to help us answer these fundamental questions about the universe. Questions about early galaxies, which I'm really interested in, but then also this ultimate question of, are we alone in the universe? So with this telescope, one of the awesome things that we hope to be able to do is really expand on the knowledge that we've gained from other telescopes like the Kepler telescope and learn in detail about exoplanets. So from the Kepler telescope, we've now learned that there are thousands of confirmed exoplanets orbiting other stars. So think about that. I mean, when I was a kid growing up in rural Arkansas, the only planets we knew of were in our own solar system. So this has been an absolute fundamental paradigm shift of our knowledge about the universe. Really just, the last 20 years, but really in the last 5 to 10 years. Kepler has changed the way that we understand how planets form. So if you go outside at night and point up at a star, almost certainly it has a planet around it. And that's something that we didn't know even 10 years ago. But Kepler has shown us that planets are common, but we haven't yet been able to study them in detail. And so what this telescope is going to allow us to do is look for planets, stars and planets that are relatively nearby. We watch the planet transit in front of its star, and then we look at the starlight that passes through the atmospheres of these exoplanets with this amazing, huge telescope. And so we need this big mirror and the really, really advanced detectors that we have on the telescope to study in detail those atmospheres of those exoplanets. So what are we looking for? Of course, we're looking for signs of life. We're looking for habitable planets. Now, finding those, really hard to do. Absolutely believe that there's life out there. Absolutely, I believe that. We'd have to sort of hit the jackpot to get a confirmation with James Webb, in its operating lifetime. But absolutely, this telescope is the next step, next big step in our search for life in the universe.
Thank you. Bobak, first Cassini, Curiosity, now Europa. How are you at JPL expanding our search?
I'm not looking for the civilizations part, because that'd be terrifying if they were elsewhere in our solar system. We hadn't found them yet. But no, I fundamentally believe. So I mean, the crazy thing is, we look at Earth, and it's this one data point to understand. Our entire understanding of life comes from one data point, effectively. But the idea now, as we kind of look out in the universe, and as well, it's kind of nearby, is that all the ingredients we believe are necessary for life exist in a variety of places, places like Mars, but also these icy worlds, these moons of Jupiter and Saturn. And with Europa, we're sending a mission there, possibly up to 2 missions there, to look for real evidence of habitability and possibly life. And that's because Europa is this moon about the size of our moon, with about 2 to 3 times the water of Earth, we believe, that exists kind of in a relatively warm ocean below this icy shell. That's what we think is there. That's what we're going to go try to confirm, and then to look for the ingredients. But it's the chemistry, it's the energy, and it's had that kind of presence for a long time. So I absolutely believe that we have the chance to find life in our own solar system outside of Earth. I think that it may not look like the Vulcans or anything like that, but we may make first contact hopefully before 2061. So I'm kind of optimistic.
With a microbe.
With a microbe, yeah. I mean, it's going to be a little different than you imagined. No James Cromwell to just kind of do this.
Can I compare and contrast to their comments?
Absolutely.
So one of the things, it's so exciting to be able to sit here and listen to what we were doing, looking way out in the distance. And let me just compare and contrast a little bit to experience of what we're doing on the space station. These guys are looking out for life outside the solar system. On the space station, our view is of the Earth. And it is absolutely beautiful. And when you're in low Earth orbit and you look out, you can see over the curvature of the Earth, obviously, and see out into deep space. There's constellations, and the view of the night sky is absolutely incredible from up there. But the one thing, when people ask me, do you think there's life out there? My answer is I don't know. But what I do know is that the Earth is absolutely unique and absolutely beautiful. And it is our, to use a cliche, spaceship. We are all crew members on this spaceship. And living on the space station, it becomes immediately clear that if you do not take care of the space station, if we aren't doing the maintenance that we need to do, if we treat the space station carelessly, that there's a very, very real probability of the space station breaking and not being able to sustain our life. So I spent about 30% of my time taking care of the space station while I was up there. It is what provides us oxygen and water, food and protection from radiation, a breathable atmosphere. And then when you look back at the Earth, it is gorgeous, but it is fragile. You can see a very, very thin blue line that separates humanity from the cold void of space. And we do not spend anywhere near 30% of our time taking care of this planet. It is fragile, it is finite, it is our home. And as we look into space, I think the other thing that NASA helps us do is look back at our planet, at our home, to study our home planet and figure out ways that we can, what we can do to take better care of it. And so I think it's awesome that we are looking outward, but we need to continue to look inward as well and maintain our home as we continue to explore.
Chell. Here, here. Thank you for reminding us that maintaining our planet is a survival issue and not a political issue. Jay, do you want to weigh in, Jay, on the search for life as it relates to your work?
Oh, no, I have to follow the astronaut with that?
No, no. We all have to follow the astronaut.
This is actually where I would weigh in less than the other panelists, because the main thing I get to do is periodically fund revolutionary new concepts. Every once in a while, people will have an idea for a new way to make a telescope or an imager, or to enable exploration into a place that we can't go now, like into a cryovolcano or down to explore the oceans under the ice. And so that's the kind of thing that some of the technologies that I'm honored to study.
I want to follow up with a question to Chell. Star Trek famously envisions a future in which exploration is very cooperative and it's independent of race, gender. Everyone cooperates and gets along in their desire to explore. And I wanted to know how has your experience in training on the International Space Station, how does it measure up with this wonderful vision that we have on Star Trek?
It's a great question. We've done some amazing things on the space station, and I think among those things, I alone got to work on over 240 experiments while I was up on the space station. And it's the reason that we have this space station. It is an orbiting laboratory where we conduct science and research to extend our presence in the solar system, but also to make life better back here on Earth. And so we're studying the human body, we're studying combustion to benefit humanity. But in spite of all of that work, I think that one of the greatest benefits that we have derived from the space station is that international cooperation piece. For over 20 years, former adversaries, so Japan, Germany, the US, Russia, have worked together to create this modern miracle of engineering. I mean, it is a truly phenomenal place to live and work. And if you can, I know many of you traveled to get here. Imagine while you're flying on that 737 that they're putting it together while you're flying here. I mean, that's what we did with the space station. Over the course of over a decade, we were putting this amazing piece of machinery together, but also living and working and doing work. Some of the pieces of the space station had not even been built when the first pieces went up. And so it's a testament to the engineering language, to our level of communication that we were able to do this safely and successfully. That partnership with these countries, I think, has provided an avenue for communication, cooperation. It has served as a keel for our countries over the past couple of decades, in spite of the direction the political winds are blowing. So I think that ultimately the space station has served as really a testament to what we were able to do when we work together for peaceful means instead of working against each other. And it was phenomenal to be a part of that, to go to Russia, to go to Japan, to go to Germany, to Canada, to train, and then ultimately to fly and have representatives from all of these countries on the space station, all of us working together for mission success and towards a common goal. So incredible to be a part of that. I felt so blessed to be assigned to a mission with the crew members that I was up there with. We all got along. Everybody's very professional, concerned about each other. Working in that kind of an environment, of course, is going to forge a bond that will last our lifetime. So absolutely amazing to be a part of an international program, and I think that one that is really reflected in a future-looking Star Trek.
All right, back to Dr. Falker at the end of the table. A fascinating part of your job is trying to make ideas from science fiction real. Now, how do you approach that? And what are you working on? What technologies that are similar to Star Trek?
Thank you. Okay, so my favorite program in NASA, well, all respect to the astronauts, I don't get to go into space, is a little research program called NIAC, NASA Innovative Advanced Concepts. And our job, in a phrase, is to change the possible. And we very much study revolutionary, controversial things to try to figure out how to get capabilities we don't have and enable missions that are either impossible or prohibitive today. So some of the things that we funded are right out of science fiction. A space elevator. Even when we don't have the materials with the strength to weight ratio required to build one, we took a look at a proposal that said, here's what material advancement is doing and where it's projected to be in 10 and 20 years, and there's a reason to believe we will be able to build one. So if we could, and the material operated like this, could we build one? People know how we would use one if it existed, but could you actually build something that big and have it become operational? And if we did that, what would it do? What would it cost? Would we actually want that? That's the kind of question, the kind of exploration that we do in a whole range of areas. We don't have a warp drive yet. We do study advanced propulsion in a number of different ways. Replicators are becoming a reality with the additive manufacturing machines. I think we'll see that within our lifetime. And I have actually studied tractor beams in 2 different forms.
Cool.
A question for Amber and then Bobak. Why do you think space exploration has become such an important part of pop culture?
Yeah, that's a great question. I think it really does come back to this idea that space exploration and NASA and science and all the things we do at NASA comes back to this idea of hope. You know, it's about hope for a better future, hope for reaching beyond what we're currently capable of. And you know, that sounds a little froofy for a scientist to say, right? That's not hard data, but you know, it's something deep about us as human beings that we want to explore and that we want to reach beyond what we're capable of. So I think it really does come down to that, and so that's why we see it in culture. You know, just last year we celebrated the 25th anniversary of the Hubble Space Telescope. Yay! So I work with Hubble data, and I love Hubble, and I love how Hubble has just absolutely infiltrated pop culture. And you can find Hubble images everywhere. They're all over the place, on YouTube or on U-Haul trucks, in music videos. Album art for some, you know, popular bands. It's all over the place, and I think, you know, the public realizes that Hubble is this amazing machine that we built that explores the universe in these really fundamental ways. And I think even just maybe a little bit beyond that, it's sort of, I guess it's not surprising that technology like the space station, this awesome thing that we've built, you know, we build things as humans. So that's sort of, you can understand why, you know, why the space station and Hubble and these machines that we build are sort of inspirational. And if, you know, you go out on nature walks, and we all enjoy getting out in nature because that's part of our experience. Why human beings think that images of nebula are beautiful is a little weirder, right? Because that's not really part of our experience. But everyone recognizes the beauty in these Hubble images, right? It's a little strange. So I don't really know why that is, but I think that maybe it goes back to, on some fundamental level, you know, we realize that we're sort of looking back at ourselves when we're looking out at the cosmos, that we're from the cosmos, we're part of it, we're part of this bigger picture, this bigger story.
Bobak?
I don't know. I have a bunch to add to that. I think the other thing it's so true, and everything that really, honestly, everything out of this program, even though I know how the sausage is made, it does not make it any less awe-inspiring to see the accomplishments of people. And I think one of the things that NASA and really all the space agencies is one of the things that's so powerful about it is it shows you what is possible when people put their minds together, when we really work together to achieve things. And I don't know that there's that many other fields that seem so cohesively, motivated to do one incredible thing. And I look at the space station, look at Hubble, James Webb, Curiosity, everything that I worked on. I mean, thousands of people working together to make, one moment kind of, and subsequent years of science happen. I think that's a very powerful emotion, and I think that's what, when I see our space program, that's what I'm really most proud of, I guess.
I was recently at JPL for the Juno insertion into orbit, and there's nothing more exciting than being in the friends and family room when you guys go nuts in the control room. It is the most wonderful feeling to watch them jumping up and down and hugging each other and high-fiving, I cannot tell you. Chell, did you use any Star Trek-inspired technology on the ISS?
Well, we don't have a holodeck yet, but we actually did have a HoloLens, so a Microsoft product, a HoloLens delivered to the space station a little bit after I arrived. Actually, they arrived 2 days before I left the space station. We didn't get to unpack them. I didn't get to play with them, but I trained on them, and I think that this is has some real potential. So using augmented or mixed reality to present not only operationally assistance to an astronaut. So as an astronaut or a crew member is looking at a piece of equipment, somebody that's following along can actually draw on reality and say, this is the bolt that we need you to turn. Or to be able to bring up procedures and look at procedures while you're working on something. And then there's the potential for a holodeck as well. It was very strange. When I first arrived on the space station, came out of the Soyuz, and we immediately go into the Russian segment of the space station to do a downlink with our family and friends that are still down in Baikonur, having just watched us launch and dock. And as I floated into the service module, I heard chirping birds, and thought that was interesting. And so our psychologists and our behavioral support folks will often send up sounds of Earth. And so I think augmented or mixed reality presents a possibility in the future of being able to sit in your backyard and listen to the birds chirp for a couple of hours while you're hanging out in your crew quarters. And so that's, I think, one very cool vision that Star Trek had that we may be able to implement sometime in the near future.
Sorry, I gotta go back a moment. So basically, if I understand the moment, a bunch of stuff came to the space station, like it was like Christmas Eve. All the presents were there, ready to unwrap, and then they were like, "No, you got to go home." Is that? Did I get that right?
So almost. I got to use the robotic arm to capture the Cygnus orbital ATK Cygnus module.
Okay, that's pretty cool.
And so my video game skills came into use there. Very cool. We docked it to the space station. We begged and pleaded for mission control to allow us to do all the vestibule ops so that we could open the hatches. And I did immediately dive in to find my crew care package, went through it all, and and this is all probably 10 hours before we're supposed to climb into the Soyuz and come back to Earth. So all the personal stuff that got sent up there, I put on a sweatshirt that I had sent up to me. I wore it for like an hour and then had to pack it away. And there was some candy and some other end notes from my family. But some of the cool stuff, like the HoloLens, were packed deep in there, and we didn't get to play with it. So we opened our presents on Christmas Eve, essentially.
Jay, I've heard of an annual event called From Science Fiction to Science Fact.
Yes.
Fact. Is that a real thing?
Yeah, thank you for mentioning it. The Chicago Museum of Science and Industry started this, so credit to them, not to me or to NASA. But they specifically asked for some of the NIAC fellows who do research in one of my programs to come to an event like this.
Would you tell us what NIAC, the acronym is?
NASA Innovative Advanced Concepts.
Right. You guys are really fast and furious with the acronyms, you know that.
We don't have time for all those words. We just go right to the acronyms.
There are acronyms made of acronyms.
Yes, there are. And it was so I went there to the inaugural event. The museum's done it 4 times, but it was really awesome because not only was there an auditorium full of people like this on their day off who came to see it, little kids lined up to ask questions of the scientists afterwards. And it was just the kind of thing that I would have loved if I had seen it when I was a kid. It was an honor to be part of it. So not only has that museum done it for 4 years and invited other fellows to come present about their work, 2 other museums have done it, and a university, and 2 others are in contact with us.
All right, now I have a question to anyone on the panel. Can you define the prime directive? Bobak, I think you're going to do this.
I can only tell you about planetary protection, which is basically the equivalent of our prime directive for NASA.
That
Is
was
good?
where I was heading,
Okay,
so
great.
go ahead.
All right, so one of the things that is crazy about this is we are actively looking for life outside of our own planet. And one of the things we want to do is when we find it, we want to be sure that it's actually foreign in origin. We don't want to carry a bunch of Earth life with us to Mars and then rediscover the Earth life that we brought with us to Mars. So there's an incredible amount of protocol associated with every mission that we send to a place that we think could be habitable. And as I kind of alluded to earlier, there's a lot of places that are very habitable, and those are the places we want to go. So with Mars, for example, we have to sterilize the spacecraft. We have to bake it out. We rub it down with alcohol in certain places, and there's like basically an acceptable limit of number of spores that are surviving that we think wouldn't make the trip all the way to Mars, and therefore it's good. But conversely, that problem applies now in return. We're starting to talk about bringing sample back from other planets, and we want to make sure that one, that anything that may be surviving in there doesn't get contaminated by Earth when we open it up, but also that we don't contaminate our own planet and start like the Andromeda strain. So we do actually have to be careful. So this is an incredible engineering challenge for all of us, is how do we keep things clean? And we have to, we are humans building spacecraft, so we are inherently covered in microbes and other things that you don't want to think about too much. But it's actually a really difficult challenge, and they're getting to the point where they're like, well, we don't want you to wear deodorant while you're assembling a spacecraft because that could contaminate our processing chain. So it is going to be an interesting challenge, and I think that's kind of surprisingly, I think, coming from an education engineering, that was one thing that they never taught me about in school, was that you were going to have to watch out for how to keep life off of your spacecraft. And you guys, I mean, you
that's
contaminated
the reason,
all of this.
That's the reason why we're doing all of our search for life right now with rovers, and because as soon as you put a person on the surface, we're bringing.
Don't mess it up for
bringing
us.
all of our
Don't
funk
mess
with
it up
us.
for us.
Well, one final question for the group. I want anyone who has a question, maybe you should line up. But this challenge of humans to Mars. Does anybody want to talk about this sort of new, reinvigorated excitement among the public for exploration in the wake of the success of the movie The Martian, and the fact that we now seem to have a ground plan to put us in orbit around Mars in 2033 and possibly even landing in later that same decade? Anyone?
So I'll just say that movies like The Martian and the recent one-year mission with Scott Kelly, the use of social media to share images from deep space, and also the experience the astronauts are having on the space station, that all of these things, I think, have really created a groundswell of interest for space exploration in general, and specifically our current journey to Mars. And we have, of course, rovers and probes examining Mars right now, with Curiosity and Mars 2020 coming up, really pathfinding for the astronauts that we hope to send there in the next 2 decades. And we see that. We see that interest actually just recently, as we had a new astronaut application. Anybody here? Awesome. So you and 18,000 others applied. When I applied, there was just 3,500 of us, so I'm glad I'm not in your class. But it's a very exciting to be a part of the space program. We were having a discussion earlier how somebody was kind of lamenting not being a part of being alive, and some of you were around and got to watch the first steps on the moon. and the first shuttle launch. And so I saw the first shuttle launch when I was in second grade. I remember watching that on television, but missed out on the lunar landings and everything. But this is an amazing time to be a part of the space program. We have, with the James Webb Telescope, with the exploration we have of Mars and the probes that we were sending all over the solar system, and then commercial spaceflight, the opportunities that are going to exist here in the not too distant future, so that more people have that opportunity to see the perspective of the Earth from low Earth orbit. I think that's going to be critically important to really understand what we need to do to take care of our planet.
All right, so please direct your question to any member of the panel. Yes.
So I have two questions. The first one is for everybody, and it's, do you think any intelligent life exists elsewhere in the universe besides, like, because microbes are possible, do you think that intelligent life exists?
Yes.
Yeah.
I don't know. I don't know if we'll find it in our lifetimes, but absolutely, I think it's out there. I mean, the fact is that our Milky Way galaxy, normal galaxy, has hundreds of billions of stars. And now, like I said, we know that planets are common around almost every star. Basically, every star in our galaxy has planets around it. But there are hundreds of billions of other galaxies. The universe is so vast, it is so huge, that I think without a doubt that there's life out there. It's my opinion, not a fact, just an opinion.
Did you have a follow-up as well?
Yeah, I have a question for Shell, or how do I pronounce it?
That's fine. I respond to just about anything.
What was it like transitioning between like microgravity and Earth's gravity when you came back from the ISS?
Gravity is a bummer. So my first interaction with gravity was basically climbing out of the spacecraft. Because our spacecraft tipped over, which is a normal configuration, but we were hanging from our straps, kind of face down, and the hatch opens this way and makes a really nice platform actually for getting out. So Oleg, my commander, got out first, then Kimia, my Japanese crewmate, and then it was my turn. And the search and rescue guys came in and unbuckled my straps, and in my brain, it made a lot of sense. I'll just get down on all fours and kind of shimmy out. And so I got down on all fours and face planted. Thunk. And just kind of laid there, help. And it was not a strength issue, because we work out 2.5 hours every day on the space station. It was just basically my brain did not understand how hard my body needed to work to counter the force of gravity. And that took me about 30 days to get over the effects of just the musculoskeletal kind of aches and soreness from being back in gravity. But after about 30 days, I felt great. Thanks for the great question.
Thank you.
They were two great questions. Would you like to moderate the next panel? Yes.
Thank you guys all. You're champions of our culture right now. Star Trek, I think, has been on a little hiatus for quite a while, and talking about the synergy between that pop culture and the reality of NASA science, you guys are taking that synergy and giving so much back to us. I'm wondering, like, how you feel that in an area like Comic-Con, like how the pop culture can reiterate that synergistic energy, like, back towards NASA and the reality, and like talked about thinking of the awareness of our planet and spaceship Earth, and how we can increase the positive kind of feedback flow with the message of Star Trek and throughout history, as well as NASA.
So it's a great question. And we were actually just talking a little bit earlier, really about the synergy that exists between science fiction and pop culture and what we're doing at NASA. And it's a cycle, because we've got the biggest collection of space nerds at NASA anywhere, and science fiction nerds. So we are inspired by pop culture, and then in turn, pop culture I think is inspired by the work that we do. But fundamentally, to help NASA do its job, to help us do the things that we would like to do, and to help the kids here come and take our jobs and become the next generation of explorers and scientists and engineers. I mean, it really requires use of the political system just to talk to your leaders, to your congresspeople, and express that support, because it is public support that our political leaders look at, and that's how government programs get funded. So ultimately, turn your passion for pop culture and for what we're doing at NASA and give it feet.
I'll add to that real quick. Just keep doing what you're doing. Everybody's here. You guys are reading the books, watching the movies, rooting for us to explore and go beyond, and that's why we're doing it.
Oh, and I'm going to drop a plug here for you, Bob, because Bob works at the Planetary Society, and they have a ton of great resources on how to actually contact your congresspeople and show that support. So there's a lot of good stuff.
Thank you. And please subscribe to my free web video, The Planetary Post, where you will hear what is cool that is happening in space every month. The Planetary Post. That was a cheap plug. All right, we only have one more question.
Okay, thanks
Pressure's
guys
on.
all for being here. All being fans of Star Trek, obviously the Doctor is our favorite character.
Yay, doctors.
We're not going to argue.
I would like to know, what is your favorite Star Trek series and why?
All right.
Go start from there.
I'm going to leave the stage. Come on, tell the truth. Run down and
All
tell
right,
your truth.
Bob.
Starting with Jay. Don't lie.
All right, I have to say the original series because I saw it first and it most inspired me.
I'll have to say Voyager because woman captain.
TNG, just because I love Geordi. I mean, like, who doesn't want to be a chief?
I'd have to say the original series. I aspire to be Spock, but I'm more like Bones.
And I'm not allowed to answer. Thank you all very much. This has been a wonderful experience.